Hello, welcome to the course project presentation of Applied Deep Learning. We have decided to call our course project the AI Book Wizard, an AI that generates book summaries, book covers, and predicts book success. This project has been done by me, Sanjana Ramana, and my partner, Karvindan Palnisamy. Contents. Here are the contents of today's presentation. Firstly, I will introduce the AI Book Wizard to you. Then in part 1, I will be talking about book summary generation, book cover generation, all the models that were used for both these processes. Then I will give you a code walkthrough and also show you the UI. In part 2, Karvindan will talk about book success prediction. Then he will give you a code walkthrough, conclude the presentation, and cite the references that we have used in our project. So let's get started. Welcome to our innovative web app, the ultimate tool for book lovers and writers alike, the AI Book Wizard. With our app, you can easily generate professional quality book summaries, book covers, and even predict the success of your book before it is published. Whether you're a reader looking for a quick overview of a new book or a writer looking to give your book the best chance at success, our app has you covered. With just a few taps, you'll have access to all the information you need to make informed decisions about your reading and writing. Now, let's jump into book summary generation. Book summarization is a process of condensing a book's contents into a shorter, more concise form. This can be useful for quickly conveying the key points of a book or for saving time when reading long texts. Traditionally, book summarization involves manual summarization by a human being. But with the advent of deep learning and natural language processing, it has now become possible to use transformers to automatically summarize books. Transformers are a type of deep learning models that can process sequential data, such as text. They have been successful in a variety of natural language processing tasks, including language translation, text classification, and summarization. By training a transformer model on a large dataset of text and summaries, it is possible to generate summaries of a book that capture the key points and the themes of the original text. There are various types of summarizations, namely extractive summarization, abstractive summarization, and multitask learning. For this project, we have used transfer learning with self-supervised models like BART and Pegasus to generate book summaries. Let us talk about BART. BART uses a standard transformer architecture like the original transformer model uses for the neural machine translation, but it also incorporates some changes from the BERT and GPT models. BERT uses a bidirectional encoder and GPT uses an autoregressive decoder. BART is a combination of both of them. A significant advantage of the BART setup is that it provides unlimited flexibility of choosing the corruption scheme, including the change in the length of the original input. Moving on to Pegasus, which is short for pre-training with extractive gap sentences for abstractive summarization. Building upon earlier breakthroughs in natural language processing, Google's Pegasus further improves the state-of-the-art results for abstractive summarization, in particular, with low resources. To be more specific, unlike previous models, Pegasus helps us achieve close to state-of-the-art results. Therefore, for this project, we have used both BART and Pegasus for book summary generation. Now, let us talk about book cover generation. Book cover generation is the process of automatically generating an aesthetically pleasing and representative image for a book based on its title and summary. With the increasing popularity of ebooks and the need for effective marketing campaigns, it has now become very important to have attractive book cover images. GANs, or Generative Adversarial Networks, are deep learning models that can be used for book cover generation. They consist of a generator network that produces synthetic images and a discriminator network that tries to distinguish real from synthetic images. GANs can learn the underlying structure of a dataset and generate diverse and realistic images. For this project, we have used a combination of VQGAN and CLIP. VQGAN acts as a generator and CLIP acts as a discriminator. Now, let us talk some more about VQGAN and CLIP. Vector Quantized Generative Adversarial Networks, or VQGANs, and CLIP, Contrastive Language Image Pre-training, are two approaches that can be combined for tasks such as book cover generation. VQGANs are a variant of GAN that allows vector quantization to improve the quality and efficiency of the generated images. CLIP is a pre-training method that uses a transformer model to learn a shared representation of the text images. By combining VQGANs and CLIPs, it is possible to generate images that are both visually appealing and relevant to a given text description. VQGAN can produce high-quality images, while the CLIP pre-training can ensure the generated images is relevant to the text description. Some advantages of using VQGAN plus CLIP are as follows. High quality and diverse images can be generated with VQGANs. Relevance to the text can be maintained using CLIPs. Efficiency can be improved. Fewer human resources would be necessary, and there would be consistency in the there would be consistency by using a machine learning model to generate book covers. That was about VQGAN and CLIPs. Welcome to the UI of the AI Book Wizard. This UI has two sections, namely the book summary generation section and the book cover generation section. The book summary generation section has two parts to it. The left-hand side is where the user gets to paste the content, and the right-hand side has two text boxes where the summaries appear. The first text box generates a summary using BART, and the second text box generates a summary using Pegasus. When the user wants a summary of a certain content, all the user would have to do is paste the content of the book here, then click Submit. In a few seconds, the summary of the book is generated. In case of authors, the authors can generate the summary of the book in this part, copy the prompt, and move on to the book cover generation section. In this section, the author would have to paste the prompt in the text prompt section, select the type of image that they want to generate, and click Submit. On clicking Submit, the output for this particular prompt will be generated. The UI was built using Gradio. In this section, we install the Gradio dependencies. After that, we install the dependencies for the transformers. In this section, we install the dependencies for the VQGAN plus CLIP architecture. Once all the dependencies are installed, we build the code blocks. In the first part, we load the BART model as well as the Pegasus model. Both of these are given as inputs. We also give the description, the bottom sentence, and then we use parallel condition within the Gradio interface. This is named as TS demo. Later, we use the generate function to write the prompt style and aspect conditions for the VQGAN plus CLIP architecture. The VQGAN plus CLIP architecture is built using Pixray. Once all the dependencies for the generator are given, the description is also defined. The final variable is called BC demo, as in book cover demo. Now we use a tab interface to generate the book summary as well as the book cover. This is how the final UI looks. Now, in order to understand the BART architecture better, we used the BART architecture to fine-tune a CNN Daily Mail dataset. In this notebook, we fine-tune BART with Blur library. Here, Blur integrates Hugging Face transformers with FastAI. After preparing the data using the CNN Daily Mail dataset, we load it into a data frame. This is the input data frame. In the next step, we get blur's get HF object helper method and we load it into the variable name, model name. Later, we pass the load data into the data block blueprint so that it can be modeled. This is called as TLS. We check the length of the train and test data, find out the length of the batch data, and finally train the model. The BART model is prepared for training by wrapping it in a blur's base model wrapper object. A new sequence to sequence metric callback object allows us to specify sequence to sequence metric we want to use. After loading the model, we plot the loss versus learning rate graph. This is how the loss versus learning rate graph looks. Post that, we fit the model and use test data to generate the outputs. As we can see, the prediction is generated for this entire data. This is how we understood the BART architecture. Now let us talk about the VQGAN plus CLIP architecture. In order to understand the VQGAN plus CLIP architecture, we use this notebook. In this notebook, we clone the taming transformers and the PixArray repositories. We imported them using the PixArray variable name. Then we called the VQGAN and CLIP model and we fitted it to the current text needs. Here the prompt that we gave was the very hungry caterpillar. As we can see, the model takes a few iterations to generate the final image. Both of these models were used within the ADL UI notebook. This is where the final model demo was created. That was about the code walkthrough and UI for book summary generation and book cover generation.
Phase one of the project involved generating summary of the book by using the content of the book. So now that that is accomplished, we then pass the summary into the next model and then we get the cover images. Now that we have the cover images ready, let's look into how the ratings of user are going to be. So the problem statement is predominantly framed in such a way that we are going to use the cover image of the book and predict the user's rating. So in order to establish this relationship, we are going to use a convolution neural network that takes the cover image as an input, and the output is going to be the user's rating. Now, when we can look into the data set. The data set consists of the ISBN of the book, the book title, then the author of the book, the year of publication, the publisher, and the image URL that denotes the cover image of the book. And another data set that contains the user ID, the ISBN, and book rating. So we are going to form a regression problem between this image URL that denotes the cover image of the book and the ratings of the user through the common ISBN. So we initially have to pre-process the data set in such a way that we establish this relationship, and we also have all the cover images ready to pass it on to our convolutional neural network. So the model is going to be designed in such a way that we initially resize all the images to a 64 cross 64 with a depth of 3, and then we pass it on to a convolutional layer. In this convolutional layer, we use 32 filters, each of 3 cross 3 dimension, and further, we pass it onto a max pooling layer, which helps in reducing the dimension of the image. We then again show it to a convolutional neural network, and we again apply a max pooling layer, and again we do a convolutional operation of 64 filters of 3 cross 3 dimension, and then we flatten them. Then we pass it on to a dense hidden layer of 64 neurons, and then we connect it to one neuron in the output layer because it's a regression problem. So the total number of parameters involved are about 646,000 parameters, which is reasonably good comparing to the large data set that we actually possess. And upon training the model, we were able to get reasonably good results. Uh, you could see that for a given cover image, the predicted rating is about 70.2. And you could also observe that upon training for multiple epochs, the losses have reduced, and we would be able to get a good rating on a scale of 0 to 100. And this is reasonably good because the training loss and the validation loss have been reducing over epochs, and they have reached a point where the results are actually going to be stable. Now, let's look into this demo. So, given that the data set, um, this is the head of the data set in which I described the essential fields, the ISBN, the image URL that contains the cover of the book, and we also have another data set that has the ratings of every book. So we initially group all the books by ISBN, as there are going to be multiple users who are going to rate the book for the same ISBN. So we take the mean of them, and then we merge it onto the other data frame, in which we can link it with the image cover. Now that we have the book ISBN number, the book cover, and as well as the book ratings, we further select only those fields and look for missing values. And we drop all the missing values that exist, and then we look on downloading all the images. So we use this we use request library in order to download all the images, and we store them onto a drive. And now let's look into the next notebook that handles the modeling part. You could see that the content of the drive is are going to be accessed, and all the images are being extracted. Also, the other data frame that contains the rating of each ISBN is also being taken into account. When the images were stored in Drive, we stored them in a form of the file name as their ISBN number. So, for all the given images present in the dataset, we are going to put them into a list and also its respective rating into a list. Before we do so, we are resizing the image to a 64 cross 64 dimension, and then we append them to a list. And now, in designing a model, we are going to be utilizing GPUs, because even with GPUs, due to the model complexity and large data set, it takes about 4 hours to run, 4 to 5 hours to run. So we add a convolutional layer with activation function of ReLU, which takes input shape of 64 cross 64 cross 3 as we have resized the image to that respective dimension. And then we use a convolution neural network and then again pass it on to a convolutional layer, and then again a max pooling layer, and again a convolutional layer, and then we flatten them, pass it on to a 64 layer hidden neurons, and then an output of one neuron. And we will be utilizing the Adam optimizer and mean square error, because for regression it's going to be mean square error, and Adam is one of the best optimizers that we have. And you could look at the model of the summary over here. We then convert all the inputs and the outputs to a NumPy array, and then we perform a train test split. Sorry. So now that we have the data set ready, we convert into form of tensors, and we then convert these data set into a data loader format. And it's going to be batched of 32, and also the data set is going to be shuffled so that the model works unbiased and is trained unbiased. So I first create a directory in order to store the best model. So for each epoch, we'll be checking how well the model performs. And in case if the model performs better, we can checkpoint the model. So I create a directory in order to do that. And then I extract the number of batches that are there in the training data set so that we could run it in a loop for so much times. And the best loss is going to be set initially to infinity, because a better model, the better the result, lower the number, and we could replace the best model. And also, in order to perform plotting between the loss over epochs, I keep track of the data using these two lists, and I run the model for 10 epochs, and I run it for the batch size. You could see that I'll be using the uh, training data set and validation data set here in order to get the data. After the model is fit, its data are being stored. The training loss and the validation loss are being stored, and then the mean of them is taken into account, and the loss history is also being appended. And then we'll see if the model has performed better than the previously stored model or produced a better validation loss than the previously stored model. So in case if we find, so we checkpoint the model and then we store them. And upon training the model, we can see that the validation loss has decreased over time, and the training loss have also decreased over time, and they have also reached a stable point where there's no room for further decrease. And now let's perform the prediction. And if you could see here for a given cover image, you could see that the predicted rating is about 70.2. The model performs pretty good. And this is a bit of demo. And now that we have, so I like to summarize what happened over here. The phase one of the project, in which we use the book cover, book content in order to generate the summary. Then we pass the summary onto the next model, and then we get the cover image. All of this was deployed further into a web application. And after that, we use the cover image and we predict the rating of the user. So these are the three phases of the project. And the references for these are going to uh, be the links that we have attached here. And thank you very much. It was fun working in this project. Thank you.